Good morning to all. I am Krishnaleela, working as an assistant professor in Department of ECE, P.S.R Engineering College. Today we have to discuss about Coulomb's law. In the study of electrostatic field, Coulomb's law is very important one. The Coulomb's law experiments are conducted by an engineer, Charles Coulomb, in 1785. The Coulomb's law experiments related to the force between the 2 point charges. Okay. So, point charge is nothing but is on electron charges. Okay. So, what is charge? Charge is a flow of electrons. Okay. So, charge on one electron is 1.602 into 10 power minus 19 Coulomb. Okay. So, charge, so consider 2 point charges in free space. Okay. So, this is a point charge. So, we point out here name Q1 and Q2. Okay. So, these two charges separated in a distance R. Okay. The dimensions of a point charge is very, very small compared to the other dimensions. Okay. So, point charge is a location, not a position. Sorry. Okay, sure, okay. Okay. So, point charge is separated in a air as a distance R. Okay. So, we have to calculate 1 Coulomb of charge. So, 1 Coulomb of charge is defined as 6 into 10 power 8. Okay. So, number of electrons form a 1 Coulomb of charge. Okay. The charge unit is Coulomb. Okay. So, we have to calculate 1 Coulomb of charge is equal to 1 divided by 1.608 into 10 power minus 19. This is equal to 6 into 10 power 8. This is 1 Coulomb of charge. Charge is equal to 6 into 10 power 8. Okay. So, next we have to detailedly discuss about statement of Coulomb's law. So, statement of Coulomb's law. In Coulomb's law, we have to find out the force equation. So, force is directly proportional to the product of two charges. Okay. And is inversely proportional to the square of the distance between them. So, from this statement we have to derive the expression for the force equation. So, F is directly proportional to the Q1 product of two charges Q1 and Q2 and inversely proportional to the square of the distance between them. Okay. So, from this diagram. So separate here 2 points as Q1 and Q2. So these charges joined by a distance R. Okay, wow. The force exerted on Q1 based on the Q2. Then we have to calculate a force exerted on Q2 based on the Q1. Okay. So from this equation, we replace the proportional value into the proportionality constant. So we have to use proportionality constant as a K. So K denotes the proportionality constant. So we have to replace proportional value into the proportionality constant K. So F is equal to K into Q1 Q2 divided by R square. The SI units of charge is Coulomb. Then SI units of force is Faraday. Then distance is measured in meters. Okay. So next we have to detail explain about proportionality constant K. So constant K is defined as K is equal to 1 divided by 4 pi epsilon naught. Okay. So here epsilon naught is the permittivity of the medium. So permittivity of free space medium. So epsilon naught is constant value. Okay. So next we have to calculate epsilon value. So epsilon is equal to epsilon naught into epsilon R. So here epsilon is the absolute permittivity. Epsilon naught is the permittivity of medium. Here epsilon R is the relative permittivity. So here epsilon R is the relative permittivity. In free space, epsilon R value is equal to the 1. So we have to replace epsilon is equal to epsilon naught. Okay. So epsilon naught is the constant value. So we have to find out epsilon naught value. So epsilon naught is equal to 8.854 into 10 power minus 12 Faraday per meter. Okay. So next we find out proportionality constant K value. So K is equal to 1 divided by 4 pi into substitute epsilon naught value here 8.854 into 10 power minus 12. So from this calculation we have to find out K is approximately equal to 9 into 10 power 9 mass per force. Okay, so this is the proportionality constant value. Thank you.